All right, so in this video, we're going to go over extraneous solutions for rational equations, okay? An extraneous solution is just a false solution to an equation that comes about throughout the solution process, okay? But it does not actually satisfy the original equation. So as always, whenever you're solving equations, you always want to check your work, plug the solutions you get back into the equation, the original equation, and make sure that it works, okay? So as we go through the solution process here, we should be good at this now. These are ones where we can use the proportion. We can cross multiply. All right, so I've got 3 times x minus 7. And on the right side, I've got x minus 7 times x minus 2, okay? So let's go ahead and distribute on both sides. So I get 3x minus 21 on the left side. On the right side, I get x squared minus 9x plus 14, okay? I'm going to take everything over to the right side. We've got a quadratic, so let's get everything on one side, set it equal to 0, and I'm going to go to the right side here. So left side is going to be 0. Right side is going to be x squared minus 12x plus 35, okay? This can be factored, so we don't have to use the quadratic formula here. That's going to be x minus 7 times x minus 5, okay? So I can get my two solutions using the zero product property here. Set each of these factors equal to 0 and solve. So I get x equals 7 and I get x equals 5, okay? So now I want to plug these back in. Hopefully you notice right away, if I plug in 7 here, my denominator becomes 0, which makes the whole expression undefined, okay? So x equals 7 is going to be one of my extraneous solutions, okay? X equals 7 does not work. It does not satisfy the original equation. If I plug in 5, it does work. 3 divided by negative 2, and I get 3 divided by negative 2. So I get negative 3/2 on both sides. So this is an actual solution. 7 is an extraneous solution, okay? So pause the video, give part B here a try, and then come back and check your work. All right, same type of rational equation here. We're going to use cross multiplication here. Okay, so on the left side, I'm going to do 9 times x squared. On the right side, I'm going to do 6 times this denominator, x squared plus 2x. Okay, distribute on the right side. That gives me 6x squared plus 12x. This time, I'm just going to bring everything over to the left side because I like my coefficient of x squared being positive. Just like over here, my coefficient was positive 1. That's why I brought it to the right side. Same thing here. I'm going to go take everything to the left side. So I get 3x squared minus 12x on the left side equal to 0 on the right side. Okay. Again, this can be factored, but we're going to use a GCF here, greatest common factor of 3x. And inside parentheses, it leaves me with an x minus 4. Okay. So again, we use the zero product property. Set each factor equal to 0. I get x equals 0 for this one. I get x equals 4 for that one. Okay, just like in example A, when I plug in this first solution, 0, I get 0 in my denominator, okay, which makes each side undefined, not a solution. It is extraneous, okay? When I plug in 4, I get 9 over 24. 16 plus 8 is 24, so 9 over 24 equal to 6 over 16, okay? Those are equivalent fractions. You can, simplify both of those, and you'll get, what's that, 3 over 8, okay? Or 0.375 as a decimal. So 4 is a solution, 0 is extraneous. So moral of the story, whenever you're solving rational equations, always check for extraneous solutions.